To understand the scheduling order simulation, let's do this demonstration together. So please take a few minutes to prepare your worksheet, the same as the worksheet shown in the screen. To complete this worksheet, we would use data from the root sheet and work center files. The worksheet and the work center files, we can see here the information from root sheet, and here the information from the work center files. We will work together to complete the schedule in this table here. So we will be asked to do the following actions. We will allow for a queue, wait and move times in backward scheduling, and we will work backward from the due date, this due date, which is the date 120, to determine the finish date for operation 20. So the finish date is this one for operation 20. We will calculate the load for operation 20. Here the load of operation 20 in number of days rounded up to the nearest 8 hours. So here we will consider that we work nearest to 8 hours per day. The formula that we will use will be total load equal setup time plus runtime multiply number of pieces, which is announced as 100 units. We have 100 units for operation 10 and operation 20. So to calculate here, we will consider 100 units for each operation, and we will calculate the arrival date here, the arrival date of components at work center 9 and at work center 10. We will repeat these steps for operation 10 and at the work center 8. So let's do it together to understand the steps and the methodology for this simulation. Okay, the first step is to calculate the load here. So here, if we consider that we have 100 units, so the load will be equal to 100 multiply the runtime and the result plus the setup time, which is common time for all the serial for all the lot of these content. The result is 21.5. We do the same calculation for operation 20. Now, to calculate the number of days, we will take the standard hours, divide by 8, because we work 8 hours per day. So it's approximately 3 days here, so we will round, and we will make the same calculation here, so it's approximately 4 days. Now we completed the calculation of the load. Let's report these information in this table to finalize the schedule. The operation in days for operation 10 is 3 days. So we'll take this value. And operation days for operation 20 is 4 days. Okay, now we need to put the days for Q and the days for the wait and move. The Q, the operation 10 is worked at the work center 8. So the Q in the work center 8 is 2 days. We will take this information here. The operation 20 is worked on work center 9. In the work center 9, we need 4 days waiting queue time. So this equal 4. The wait and move is in the work center file. So for the work center 8, the wait and move is wait 1 day plus move 1 day. For work center 9 is 1 day 2 plus move 1 day. Now we have all the data to complete the schedule. If we need to finish here at 120, the day 120, we have to consider the last component of the lead time, which is wait and move. So 120 minus 2, the finish date will be 118. So operation 20 should finish at 118. We need to consider that there is operation time and the queue time to calculate the arrival date. So here the arrival date equal 118, the finish date, minus the operation time minus the queue time, which is 110. 110 could indicate the finish date for the previous operation, which is operation 10. But we have to consider that there is wait and move between the two operations. So the finish date will be 110 minus the wait and move time. 108 is the finish date for operation 10. Now the arrival date should take into account the queue time and the operation time. So the finish date minus the operation time minus the queue time, 104. So this way you can complete a schedule for different operations, considering data from the root sheet, data from the work center files, and some simple calculations.